Hey, you are watching AliAziz YouTube channel.
Reliability Engineering, for fresh and experienced candidates. AliAziz Quality Education channel providing you the job best interview related videos, so don't forget the subscription button. Index. Introduction to Reliability Engineering. What is reliability engineering? Introduction to Reliability Engineering. Every day we rely on certain things to operate properly. When we rise in the morning, we turn on the lights and many of us will make coffee. If the coffee maker fails to operate properly, it makes for a rough morning. In general, we live in a country with a reliable power grid, so we just assume it will always be there whenever we need it. There are many examples of products we depend upon every day. For example, when you leave for work, you expect the car to start, and as you travel, it is always advantageous if the brakes and steering work properly as well. For many people, one of the most important products we rely on is our cell phone. When we stop and think about it, many things we use every day are reliable. If any one of these items was to fail to operate properly, it could have a wide range of impact on our lives, from a simple inconvenience to a possible emergency. The fact is that we expect the products we purchase and the services we use to be reliable. We depend on them to operate properly on a continual basis. Companies must produce reliable products in order to maintain or expand their customer base. The reason that many products, machines, or services do work as needed, and when needed, is the application of reliability engineering. What is reliability engineering? Reliability engineering concentrates on the estimation of risk, calculation of probability, and prevention of failure over a product's lifetime. The purpose of reliability engineering is to ensure a product will consistently meet the customer's expectation to perform their intended function or functions over a set period of time under specified conditions. Reliability engineering concentrates on the costs of failure, including machine or system downtime, spare parts inventory, repair equipment, and possible warranty cost. Reliability engineering employs many types of analysis. The mission of the reliability engineer should be to identify potential reliability problems as early as possible in the product life cycle. To proactively improve product reliability, the design for reliability process is implemented during the design stage of a product. Design changes are easier and less expensive to make early in the product development rather than after capital expenses, product launch, or during full production. Effective reliability modeling can predict a product system or component's reliability prior to implementation. Reliability engineers must not only be proficient in the use of proper methodologies and analysis tools, they must also know which tools are most effective during each phase of the product development and throughout the product life cycle. Some examples of tools used in reliability engineering include, but are not limited to: Variable analysis, sometimes also referred to as life analysis. Variable is an effective tool used for analysis of historical failure data and producing failure distributions. Fault tree analysis, FTA, a top-down approach which starts with defining top-level issues, then using a deductive approach, incorporating both parallel and series combinations of possible failures, to determine the root of the problem and take corrective action prior to its occurrence. Failure mode and effects analysis, FMEA, an examination of potential failures that may occur and their effects on any part of a system, along with determining the possible causes of failure and their likelihood of occurrence. Accelerated life test, ALT, a method of time-based testing by increasing loads in order to produce age-to-failure data using few data points. The data points are scaled to replicate the normal loads. Highly accelerated life test, HALT, performed by heavily stressing the product to rapidly induce failure modes, thereby identifying weaknesses in the system. HALT tests are stress-based rather than time-based, acceleration factors are not the primary focus. Reliability-centered maintenance, RCM. This process is used to determine the maintenance requirements for a system or production process to ensure their consistent operation within desired parameters. RCM is often used to identify and establish safe minimum levels of maintenance. The numerous reliability tools work together to gather information regarding the product reliability and reveal potential problems. The reliability engineer, along with the product team, can analyze this information and develop appropriate corrective actions and product improvements. In general, the main goals of reliability engineer are as follows. Apply engineering knowledge, experience, and proper tools to predict, prevent and/or reduce the likelihood of product failure. Identify and analyze any failures that do occur and determine their root cause. After all, we cannot prevent 100% of possible failures, but we can determine the true cause and address them. Develop and implement effective corrective actions when failures occur and identify the root cause to prevent repeat issues. Utilize methods for estimating risk and reliability of new designs and study reliability data. Therefore, the most important skills required of a reliability engineer include capability to understand and anticipate possible failure modes, their causes, and how to prevent them. In addition, the reliability engineer must be proficient in the use of methods and tools used to analyze designs and data. As previously stated, they must also know which tools are most effective during each phase of the product development and throughout the product life cycle. Reliability engineering, when implemented properly, can work to predict and prevent product failures, thereby reducing warranty costs and increasing a business's bottom line and solidify brand equity.